Okay, so double replacement reactions, it's just like a single replacement, only what's driving the reaction is actually whether or not you produce a precipitate, which means that in solution, when you mix them, you create a solid. Or if a gas is produced, or if there's neutralization, which means you take an acid or a base and you make it neutral. The ones that we're typically going to work with are ones that produce precipitate, which means that they form a solid. So if you look at number one, what we're going to do is just look at what would be the products of a double replacement, meaning that iron is going to swap places with silver. So let's just write the products out. Iron nitrate. I'm not going to worry about the new formula for now. Just recognize that this little 2 right here means that Fe, iron, has a 2+ oxidation state, which means that you're going to need 2 nitrates. So if iron has a 2+ oxidation state, you're going to need 2 nitrates when you write the new formula. Nitrate is a 1- ion, so when you crisscross that number, you just put a 1 there. But remember, in chemistry, we tend not to write the 1s in, so we're simply going to have iron nitrate the way that it's written here. Okay, and then you'll also have silver chloride. Silver, if you look at this formula, must have a 1+ oxidation number because there's only 1 nitrate. So we can just write AgCl because Cl has a 1- oxidation number. Ag has a 1+. When you crisscross them, you just get AgCl. We don't write the 1s in. All right? So these would be the products if they did do double replacement. The question is, do they? Well, something has to be insoluble in order for this to happen. So let me grab my highlighter. If you look at the chlorides, it says most halogens, chlorides, for example, bromides and iodides, most of the halogens are soluble, actually, except for silver chloride. So you can see now that this chemical here is actually going to be a solid. It's going to precipitate. I'm going to write a downward arrow just to indicate that this is going to come out of the solution. So if that's coming out, then this one is aqueous, meaning it's dissolved in water. Okay, so let's try that again down here, number 2. Look at iron and barium. We're just going to swap their positions and write the products, and then we'll think about whether or not this reaction will actually take place. So we're going to get iron chloride, and you can tell from the way that this formula is written that iron has a 3+ oxidation number here. Remember, iron's a transition metal, and it tends to have more than 1 oxidation number. So in this case, it's 3+. So when we bond it to Cl, we're going to need 3 of them. Cl, chlorine, has a -1 oxidation number, so we're only going to need 1 iron. Okay, so it's FeCl3. We'll think about whether or not this reaction takes place after we write the products. We're going to have barium, and it's going to bond to sulfate. Sulfate is a -2 ion, and barium is a 2+ ion. So that means you're only going to need 1 of each. You're going to need 2 of these and 2 of these, so that means 1 to 1. 2 to 2 is 1 to 1. So we just write barium sulfate the way that's written right there. Now let's consider the sulfates. Are sulfates soluble? That's the question. Let me grab my highlighter, and you'll see that over here it says sulfates are actually soluble except barium. And so the result is that this chemical, barium sulfate, will be a solid. We'll write S for solid. It will come out of solution. It will precipitate. So what's driving this double replacement reaction is actually whether or not something will be insoluble, whether or not it will be solid when it's finished. So write the products first, then consider the solubility using the chart. Good luck.